Hello children, today let us learn construction. This is more easy chapter but yet very important for your exam. And let us read 11.2. First sum. Draw a circle of radius 6 centimeters from a point 10 centimeter away from the center. Look here, you need to focus on this point, away from the center. Sometimes it will be given away from the circle. So do concentrate while constructing. I will tell you what is the difference between that. So 10 centimeter away from the center. Construct pair of tangents. So here 10 centimeter away from the center. So I have taken center to be O and point P which is away from the center, that is P. Now measure in your compass 6 centimeters because the circle radius is 6 centimeter. So measure here 6 centimeters and then draw a circle at O. At this point, draw one circle with center O. So this we will call it as a given circle and we'll name this as C1. Okay. So listen carefully so that you can write the steps of construction. First one, draw a line 10 centimeters with O as the center of the circle C1, 6 centimeters. So how much we will get here? This is 6 centimeters. Now we need to draw perpendicular of OP. So keep it compass at O, measure more than half nearing up to P, then one arc up and one arc down here, and then from P cut this arc, yeah, then join the perpendicular 90 degree. It will be perpendicular bisector. Let it be in a dotted line because this is not main part of our construction. Make this one midpoint M and then we will be drawing one more circle with OM. See, circle C2 with OM or MP. Both will be same. OM or MP as the radius. So draw the circle with OM or MP as the radius. You can see here this one is the new circle C2. C1 and C2 intersect at these 2 points and we will call this point as R and S. You can name it anything. Now draw the tangents here. Draw the tangents from point P, from P to R. Look, extend it, do not restrict here. The tangent should touch the circle at one point and move ahead. Then this side also, because they are asking for the pair of tangents from here to this side. Fine. So these are the PR and PS are required tangents. Now we don't have justification over here. We'll be verifying the length. They asked us to measure the length also. So length over here is, I'm getting here 8 centimeter. Yeah, 8 centimeter exactly. So we will verify. For verification, we will draw here, connect radius this way. Any one side you can do this. We know this part OP becomes diameter of this circle C2 and semicircle. This is a semicircle, and according to circles the tangent and the radius both are perpendicular to each other, so this will be 90 degree. If I take up that triangle over here for verification, triangle ORP, you can draw it here. This is not necessary. So ORP in this case. So distance here is 10 centimeter. Radius is 6. So this becomes radius. This part is radius. So it is 6 centimeters. Now, according to Pythagoras theorem, OP square is equal to OR square plus RP square. So OP square here is 10 square equal to 6 square plus we have to find out RP square. So RP square is equal to 100 minus 36, that is 64. So we get RP equal to square root of 64, that is 8 centimeters. Yes, when measured by scale also you get here 8 centimeter. Our required tangent and they both are equal to 8 centimeter. You can measure both. We have theorem RP will be equal to PS. Okay, hope you understood the first one. The second sum, construct a tangent of circle radius 4 centimeter from a point on a concentric circle. Construct tangent to circle of radius 4 centimeter. To circle of radius 4 centimeter from where? From a point on a concentric circle of radius 6 centimeter. So there are two circles, C1 with center A and 4 centimeters. C2 also center A because they are concentric. Concentric means same center, different radius. So same center and radius here is 6 centimeter. So I have drawn already here for C1. This circle is of 4 centimeter radius and this is the bigger one is 6 centimeters. Here from this point, this is a common center from where you have to draw the circle. Now moving on with here. This radius is 4. Since the same center, we extend it up to this point. So they say from the point P, from point P, just we are naming it as P, on the concentric circle. So this from point P, we have to draw tangent to circle C1. That is what it is mentioned. So here again AP, we have a line. So draw perpendicular bisector of AP. Same method to draw it. Keep your compass at A. Take more than half. That is, focus only on this line AP. Keep it here. One arc up, one arc down. Just simple 90 degree what you used to do. 9 standard or perpendicular bisector, the same thing. Again draw dotted line. Here it's not mandatory to draw dotted line. So your construction looks good in that case. So it is M over here. M I take it just to remind us it is a midpoint of AP. So now we will have one more circle with AM or MP as the radius. Let it be perfect that the circle should touch A as well as the circle C3. We will need this extra circle. What we did, we bisected AP and then here this we will call it as C3. The new circle which we have given from our side, that is C3. Here you can see again focus on C1 because for C1 we have to draw the tangent, and C3 where these two circle intersect. The point of intersection here, this point and this one, C1 and C2. So now draw the tangent from point on P to circle C1. So be very careful, the line should touch outside and extend it. Then from P onto this point where these two circles intersect. Here, name it anything, P, X and Y. P, X and Px will be equal to Py. The circles theorem. So Px will be equal to Py and they are the required tangent. Now here they have asked us for the verification. For verification we will have to draw the radius here from A to X. Line drawn from center to circumference is the radius, and then this one will be AXP will be 90 degree. So we will pull out the triangle AXP for the verification. So in triangle AXP, since the triangle is not covered in the screen, so I will just pull out. This is 90 P hypotenuse, so it will be AP square equal to ax square plus xp square. Now what are the dimensions here? AP you can check here. In this case, from here to here it is 6 centimeter, radius of the big circle. And then AX will be radius of the small circle from center to the blue circle, that is C1. So this is how much? 4 centimeter. We have to find PX. So AP is given 6 centimeter or 6 square. Then AX is 4 square. We need to find XP square. So we will get XP square equal to 36 minus 16. So we get XP equal to square root of 20. Find out square root of 20. So square root of 20. Do it by division method which you learnt in 8th standard. This is 4, 4, 16. Then 4 remaining, 4 plus 4, 8. I hope you all remember this method. So me not focusing more on this part. 8, 8. I think next it will go this 4 times, 336 here minus, you get again 64, 0, 0. We will just add up again 4 in this case, 8, 8. Find out the other number, it will come up to 6 or 7. So we will approximately write it as 4.5. So now we will measure here whether we got 4.5 or not. Check out this part from here to here. See, exactly we got 4.5. You can check out 4.4 or 4.5. Just write here. Therefore, PX equal to PY equal to 4.5 centimeter measured. Here also 4.5 verified, and here measurement is 4.5 centimeters. Third sum, exercise 11.2. Here in this question, circle is 3 centimeters. So circle C1, one circle C1, I have taken center O and it is 3 centimeters. They say to extend the diameter at 7, we need points P and Q at the extended diameter. So what does that mean? We will draw a diameter here. Say diameter, this one, and they say extended diameter each at a distance of 7 centimeter from the center. This is important. So from center, here it is extended up to 7. So 0.71. We will take this as P. From here you extend 7 from center to 7 centimeter this side. So this is say Q. Anyway you can write it as a PQ or this side PQ. So we will focus this as this side one sum separate until now what we did, and this side another sum. So you just check out OP as a straight line, a line. P is an external point P, and then for this OQ. So we will do perpendicular bisector for OP and OQ. We will get 2 circles here. You can do it at a time. That is first perpendicular bisector, more than half, 1 arc up and down the way we draw the bisector. From P here go to O, then Q. You first can finish up this part and then work out. No problem in that way also. Draw the perpendicular bisector here, join these two. Again we get here M as a midpoint of OP. This side also same thing. We'll take here as M. Now with M here this way, from P to the circle C1 we'll draw tangent, from Q to the circle we'll draw tangent. So OP take M here in this case, OM or MP as the radius. Draw circle, one more circle. Then this side also circle from N to O. Because both are same, it will be same. Yeah. Now the perpendicular bisector and the extra circle from our side which we give it, that this is the given circle C1, this is 3 centimeter this side, this is 3 centimeter, this is from OP and OQ are the distance that are 7 centimeter each. Now here you can see this C1 and say make this as C2. They intersect at common point, say P, I will take S and R, join from external point P to circle C1. The tangents are drawn from the extended diameter. So from P to this way. So from C point P to circle C1, PS and PR are the tangent, and from here where we will draw this point and this one, C3, where C1 intersect C3. Forget about this circle on this side. Here. From here draw it, extend from Q here. You can name this X and Y. So QX will be equal to QY, and they are tangents from external point, extended point on the diameter, that is Q, to circle C1. QX and QY are the tangents. If you want to verify, you just can join it and then take this one as 7 and 3. So you will get your answer. But verify only if it is asked.